Today we're going to look at 2.7, which is equations of lines in the coordinate plane. I just want to go ahead and give you a heads up that we have this set of notes and one more set of notes before we take our second exam in this class. So that second test will probably be Friday of this week. So I just want everybody to be aware of that as we move forward through the remainder of this week. For the review, we're just doing true, false. The first one, an ordered pair describes the location of a point in the coordinate grid. That is true. Anytime we have an ordered pair, it does give kind of an address of where a point exists in the coordinate plane. An ordered pair can be written as a x-coordinate, y-coordinate, or y-coordinate, x-coordinate. That is false. We should always write it as an xy ordered pair. And then the ordered pair for the origin, that's where the x and y axis intersect, is in fact 0, 0. Oh, man. Okay. So the vocabulary builder, we're talking about slope. This should be a refresher basically from your algebra class. Slope is rise over run. It's the change in the y values over the change in the x values. So we can write it as this y2 minus y1 over x2 minus x1. I do know that sometimes people get that backwards, and the only thing that I want to stress to you is that if you do get it backwards consistently. So if you do y1 minus y2, the denominator has to be x1 minus x2. You can't flip one of them around and leave the other one alone. So that would not be the same as, let's say you had y1 minus y2 over x2 minus x1. That is not equivalent. So you do not want to do this right here, or vice versa, and then flip the numerator and denominator, because what's going to happen is you're going to end up getting a sign change in your final result. But what I have written there in blue, what's left on the screen, that is acceptable. So you can do y2 minus y1 over x2 minus x1, or you can do y1 minus y2, as long as you do x1 minus x2 in the denominator. I'm going to skip the use your vocabulary once again, using different forms of slope, and the same thing for 7 and 8. We're just talking about adjectives and nouns. So we'll go on to problem number 1, finding the slope of a line. Using the graph at the right, we're going to find the slope of line A, and line A is this blue line that I've now highlighted in pink. You know the slope is the change in y over the change in x, which is y2 minus y1 over x2 minus x1. The 2 points on line A are 2, 3, and 5, 7. So sometimes when you're given ordered pairs, it may help to go ahead and label these ordered pairs. So I'm going to label this x1, y1, x2, y2, and then that makes substitution easy. What I end up with in the numerator is 7 minus 3, and my denominator is 5 minus 2. 7 minus 3 is 4, 5 minus 2 is 3, and there's my slope, 4/3. Slope-intercept form of a line is y equals mx plus b. M is the slope, b is the y-intercept. The point-slope form of a line is y minus y1 equals m times x minus x1. Again, we have the slope is m. But what's different about this one is we're using a specific x-coordinate and a y-coordinate. And then we can simplify the point-slope form down to slope-intercept form. So let's graph problem number 2. And the first question is, what form of this equation is given? Well, we can see that this is the same as y equals mx plus b. So that is the slope-intercept form. Written as a fraction, the slope is 3 over 1. We can see the slope is given right here as 3. And then 1 point on the graph is going to be 0, negative 4. And we know that because we have the y-intercept is negative 4. Anytime you have a y-intercept, your x value is always going to be 0. So that's how we can say that point 0, negative 4. And then from that point, we move 3 units up and 1 unit to the right. That's what the slope 3 over 1 indicates to us. So if we were to plot this on the coordinate plane, we know a point on the graph is 0, -4, and then we would go up 3 units, 1, 2, 3, and then over 1. Then we could do it again if we wanted to, 1, 2, 3, and then over 1. And all you have to do is draw your line through those points. And there's your line that matches the equation 3x minus 4. And then you can also verify this graphically using a calculator, or if you want to use Desmos.com, you can do that as well and plot this graph. Writing the equation of a line with problem number 3. What's the equation of a line with the slope -1/2 and a y-intercept of 2? Pretty soon you'll get to the point where you don't need to follow all these steps. You can immediately write that equation without any difficulty because you'll see how all these things relate to one another. But for right now, if it helps, just use the steps and methodically go through with this approach. The first thing we know is that the slope is -1/2, and we know that the y-intercept is +2. Well, we have a slope and an intercept, so that means we should use the slope-intercept form, which is y equals mx plus b. And now we just substitute in everything that we know. So it's y equals, our m in this case is -1/2, and our slope-intercept, or our y-intercept is +2. And there's our equation. With problem number 4, we're going to use the point-slope form of a line. And the point-slope form of a line comes in handy when we know either the slope and a point, or if we know 2 points and we can calculate the slope from those 2 points, and then we can pick either one of those points and write the equation. We can use the equation, or the 2 points that are given on the line at the right, to show that the slope of the line is 6/5. So one equation of the line is y minus 5 equals 6/5 x minus 3. What is an equation of the line if we use -2, -1 instead of 3, 5? We want to take this, we're using point-slope form. And all we've done now is substitute. So there's our y value and there's our x value from the given ordered pair. And so this is just simply substitution. And then our last step is simplification. And what we're going to do for the next part of this on number 18, this equation and this equation, they look completely different, but in reality, when we simplify them down to slope-intercept form, we will find that they are exactly the same equation. And we would expect that, given that they both are generated by a point on the same line. They both use the same slope. But in the end, when we simplify everything out, we do find that they are the exact same equation. So for the first equation here on the left, we're going to distribute the 6/5 through the parentheses, and that's going to give us y minus 5 equals 6 over 5x minus 18 over 5. And our last step is to add 5 to both sides. And since I'm adding a positive 5, that's 5 over 1, which I can also write as 25 over 5. That's still adding 5, but that just helps with the denominators. So when I simplify the left-hand side, I get y equals 6/5 x plus 7/5. If my equations are correct, then when I simplify the right-hand side, I should get the exact same thing. So I have y plus 1, distribute the 6/5 through the parentheses. Now I'm going to subtract 1 from both sides. And rather than just subtract 1, I can rewrite this as 5 over 5 so that I have my common denominator. because 5 over 5 is still simply just 1. And simplify. And I get the exact same equation. For number 19, underline the correct word to complete each sentence. The equations are the same. Choosing negative 2, 1 gives either the blank, it gives either a different or the same equation as choosing 3, 5. It does give the same equation, and the two equations written in point slope form. So this equation compared to this equation, they are equivalent, and we've proven that in the two blocks above. Problem number 5, and then we'll have our set of notes wrapped up for the day. What are the equations for the horizontal and vertical lines through 4, negative 3? So horizontal and vertical lines have different properties than our lines that have a distinctive slope where it's, I hate to say it, but where it's kind of angular as opposed to horizontal or vertical. So true or false for 21 through 22, every point on a horizontal line through 4, negative 3 has a y coordinate of negative 3. That will always be true. Anytime you have a horizontal line, the y coordinate never changes. The only thing that does change is the x coordinate. For 21, the equation of a vertical line through 4, negative 3 is y equals negative 3. That is false. Horizontal lines are in the form y equals, and vertical lines are in the form x equals. So 22, it says the equation of the vertical line through 4, negative 3 is x equals 4. That is true. If I were to graph the horizontal line through 4, negative 3, horizontal lines, as I mentioned before, let me write this down here for you. Horizontal is y equals some constant, and then vertical lines are going to be x equals some constant. So for our purposes, the horizontal line that goes through 4, negative 3 is y equals negative 3. And then our vertical line is going to be x equals the x coordinate of positive 4. So anytime you see y equals a constant, it's horizontal. Anytime you see x equals a constant, it is vertical. And our lesson check, classmate found the slope of the line passing through 8, negative 2 and 8, 10 as shown at the right. Describe your classmate's error and then find the correct slope passing through the given points. What this student has done, they have done x2 minus x1 over y2 minus y1. They have found the difference in, they found the correct values, but they have them in the wrong place. And this is kind of what I illustrated at the beginning of the notes when I talked about slope. It's always the change in y over the change in x. It's rise over run, not run over rise. So let me just write that out here. It's rise over run. Not run over rise. And that's what this student has done. They've done the change in x over the change in y. So if we were to correct this student, what we're going to get is the slope is equal to y2 minus y1, x2 minus x1, and that will give us 10 minus negative 2 over 8 minus 8, and we get 12 over 0. 12 over 0 is undefined because we're dividing by 0. So anytime you have the denominator go to 0, your slope is undefined. And that results in a vertical line. Vertical lines have undefined slope. And horizontal lines have 0 slope. So that anytime you come up with a line that has a slope of 0, it's horizontal. Anytime your slope is undefined, you have a vertical line. I hope you guys are doing great. I'm looking forward to seeing everybody in class. I know when you watch this, you'll probably already be in class, but I'm making this on Monday. I don't know, we need like a time machine. Anyway, you guys have a great day, and I'll be talking to you again soon.